Welcome back my friends. In this video we're going to discuss a lot about VRF-Lite. So previous video we have discussed the basic what is VRF-Lite, how we can configure. So I also decided to create a very good document for you people and available it free for you. I highly recommend you go ahead and download those documents that I'm talking about, so you can go and develop your video whatever you're looking for. Means right now you're looking for the VRF video second, so find such kind of link, click on it and download that document as well. In this document I decide to keep all those things, means frequently asked question about VRF-Lite, like what is different, where we need to implement, how does it work, and so on and so forth, along with a very good example and the command that we need to execute. So you can see again and again. So in earlier video we have discussed how to implement a VRF-Lite using OSPF. In this video we'll discuss how we can perform static routing inside your VRF-Lite, how we can implement enhanced IGRP, RIP or a VGP. So all those things I have already mentioned in these documents. Go ahead and download. But in this video I am going to use this topology to demonstrate about VRF-Lite little bit more. So in this scenario I have two customers, one is known as red, you can see right there, and second one is a green. Look right there. So as we know, VRF-Lite create your routing instance separate, so you can assign same IP address or overlapping IP address to your customers. So similarly I am going to use on that way. The difference is that right now I am going to use only two router, since two router is more than enough to clear out your concepts and configuration. Rest of task will be performed by your customer. You need to work out with these two routers. Since you are working like ISP, suppose either you are working on backbone routers, so that is not a big deal to go ahead and configuring rest of router. So that is very good. So let me turn on my devices so that I can demonstrate it, and I can share you how you can troubleshoot, how you can configure enhanced IGRP, how you can configure RIP, and how you can configure static routing inside your VRF. Since these are little bit different or slightly different to each other and their command as well, so sometimes it's become a problem for you people. So suppose this is bonus for you, how we can implement enhanced IGRP, RIP and static routing inside VRF-Lite. So let me pause the video and turn on the devices and coming back to you. So I have turned on my devices. You can listen the sound of devices, means the working device, sound of working device. So this is the scenario where we have two router. I am going to use 2901, means that is branch as well as HQ router, and running iOS 15.0. What I am going to do, I am going to use two loopback from branch as well as HQ, so that they can simulate as a customer red and customer green from branch as well as HQ. So let me take my console. So I am going to use my secure CRT as a terminal emulator software. Right now I do not require my terminal server, so go ahead and turn off the terminal server. not turn off actually. Good. So go ahead step by step with me. So going to select interface loopback 1, and then after before creating loopback interface, I should also create first I should create IPVRF and red. Another is IPVRF green, so GREEN, and then after I am going to loopback 1 IPVRF forwarding red. So make sure first you apply your VRF, then after IP. Otherwise what happen, if you have already provide IP address to particular interface, and then after you provide the VRF, means attaching particular VRF, your VRF going to remove the IP address on that interface, because your IP address can be overlap. So then after you can use overlap IP addresses. That's why your VRF going to remove that IP address. So that's why first I would like to attach VRF, and then after corresponding IP address, as you can see on topology 255.255.255.0, no shutdown. So you can also apply a description, means this is going to work with customer red, but right now I am going to leave it as it is. Similarly there is green, so GREEN, and IP address are same as we can see there, no shutdown, because you can use overlap IP address in VRF. Go ahead on interface gig 0/0. On main interface I am going to only enable that particular interface, and then after going to select sub interface, because I would like to keep these customer and these customer separate, and make sure on particular interface you cannot attach multiple VRF. That's why I am going to create sub interface from on branch as well as on HQ. So these all things actually I have better described. Everything is written on documents, so that's why I am highly recommend you just download that document and then work with me. First encapsulation.1q, and then after IPVRF forwarding, this is for red, and then after IP address you can see 10.10.10.1 255.255.255.252, and then after no shutdown. This is sub interface. Actually you don't require to run no shutdown command, but right now I'm going to execute. So this is green one, and same IP address. Oh, I need to provide the encapsulation first. This is 2, and then after IP address. Okay, there we go. Hop over to HQ router, and first I would like to configure my gigabit interface, no shutdown, interface gig 0/1.1 encapsulation.1q, and then after first I need to create IPVRF red and IPVRF green. Let me hop over particular interface, and then after IPVRF forwarding red using this interface, same interface I am going to use. Make sure both side you are going to use the same VRF-Lite. So that's why. And then after IP address 10.10.10.2 255.255.255.252, no shutdown. And next interface, that is gig 0/0.2, and go ahead assign the VRF, that is actually green, and then after encapsulation as well .1q2, and finally IP address. And let me exit out and go ahead interface loopback 1 IP address first I would like to assign the VRF. So IPVRF forwarding rate, and then after IP address 192.168.2. This is supposed to be 2.1. Oh, I taken mistake. Just let me fix it. Okay, there we go. So that should be 2.1, 255.255.255.0. no shutdown. I would like to also tell actually what happen if you are going to use the same IP address to the two same site or two same customer. This is so problematic. You can just understand this. This is not possible. Same network you are going to use on branch router as well as HQ router. Since obviously these two customers are different, or actually they are running two virtual instance of router. So physically we have two router, but logically there is 4 router. That's why they are not overlapping to each other. But the example I taken means I committed mistake. That should be 2.0 and 2.0. Okay, so good. And next is loopback interface 2, and then green, GREEN, and then after IP address 2.1. Hopefully we will able to see all the interface up. So gigabit 0/0 unassigned, down and down. Should I execute no shutdown on main interface? Hopefully I have also executed the same command on branch router. So down. Let me fix. Maybe this is because of the cable. Okay. Actually I forget to connect the cable on that particular interface. So I have done. So hopefully now all interface should be up. Exactly, they are up and they are working. And as we know, the network 192.168.1.0 and the network 192.168.2.0, they connected to different router. That's why we required routing. The LAN, this LAN connected left hand side. If want to talk to LAN connected right hand side, that is 2.0, there should be some kind of routing. It can be static routing, it can be dynamic. So in previous video we have discussed dynamic routing using OSPF. But this video we are going to discuss how we can implement RIP, and then after enhance IGRP, then after static routing. So these 3 topics we are going to cover up in this video. So let me implement RIP. So router RIP, and inside RIP address family IPv4, and then after I am going to select VRF. I copy that. So address family IPv4 VRF, and I am going to use VRF RAID, and then after the network connected to the RAID, one network 192.168.1.0, second one is 10.10.10.0. I am going to use RIP version 2. This is for customer RAID, and now going to use for customer green. Similarly version 2, and then same network is already attached. As you know, there is 192.168.1.0. So we have successfully execute the command on branch router. Now we need to go to the headquarter and execute the relevant command. So router rip, and then after address family IPv4 VRF for customer RAID, and then after the network 192.168.2.0, and then network 10.10.10.0. Would like to use version 2, and this is your customer green, and network version 2, and network 10.10.10.0 as well as 192.168.2.0. So now we can verify the routing table. If we execute the command show IP root, means that time we are going to look up global routing table, but global routing table there is nothing we can see because we are running VRF-Lite. So VRF-Lite, it keeps separate routing table from the global. So we need to execute command show IP root, and then after VRF and the name of VRF. So RAID, we can see by rip on RAID VRF we able to see the network 192.168.1.0. so we can reach using rip, we can reach on from branch to HQ to branch using RAID 1 VRF RAID, and similarly another is green. There we go. So everything is fine, happy. Now we need to check that they are able to communicate or not. So what I'm going to do, I'm going to use ping, and then after a special command VRF, and then name of VRF from the RAID. So I'm going to ping VRF RAID from, this is the source, and then destination IP address 192.168.2.1. I will get reply back. Similarly, I can also use VRF green, so GREEN, and I will get reply back as you can see. So go ahead and show IP root using VRF RAID. There should be network 2.0 that we learn from the RIP, and then after you can also verify green one as well, the network 2.0 that we learn from RIP, and we can send data using gigabit 0/2, and earlier one gigabit 0/1. So actually they are separate to each other, they can able to ping out, and now we just need to attach the router from HQ as well as the branch. So I'm not going to do that thing, means that is not a big deal for you people. So after the RIP, it's time to apply enhance IGRP. So go ahead, select router enhance IGRP autonomous system 1, and then after I'm also going to apply enhance IGRP router ID. You can leave it if you like. So that is 1.0.0.1, and nothing special I'm going to do in global, means globally routing table. I'm going to select address family like RIP, and then after IPv4 VRF and the name of VRF, that is RAID, and then after I would like also mention the autonomous system. Since we running the virtual instance of router, so you can use same autonomous system for your VRF RAID, VRF green as well as a global routing table. So the same thing I'm going to apply to prove that. So address family IPv4 VRF, the name of VRF is RAID, and then after autonomous system, that is 1, and notice that I have also selected autonomous system on global routing, for global routing. This should not be identical, means I mean to say that you can select your own. And similarly enhance IGRP router ID 1.0.0.2, 2, and then what network you like to add. I would like to add all those, and switch over to the next one, or go ahead and create for green, and network 0.0.0.0, 0.0.0.0, and if you like to implement router ID, you can. So 1.0.0.3. So we have configure on branch router. Go ahead and click on headquarter. So router, enhance IGRP autonomous system 1, enhance IGRP router ID 2.0.0.1, address family IPv4 VRF, VRF, and then after the name of VRF is RAID in autonomous system 1. Make sure from branch as well as HQ should have the identical autonomous system to form neighbor adjacency. Enhance IGRP router ID 2.0.0.2, and then after the network 0.0.0, you can specify your network for, but now I am going to select all those network, and you can see I have already performed neighbor adjacency using enhance IGRP VRF. So now go ahead and configure green one. So the name is green autonomous system 1, and enhance IGRP router ID 2.0.0.3, and then network 0.0.0, 0.0.0. Good. So yes, we form neighbor adjacency for VRF-Lite or green, I should say VRF-Lite green, or customer green. So now we can verify a command, so IP enhance IGRP neighbor. So we can see there is no neighbor adjacency form, because in global routing we not configure anything inside global routing, means we didn't configure any network inside global, but yes, we have configured network inside RAID as well as inside green. So if you like to configure global routing, means if you want to exchange some routing information maybe for other customer using the global routing table, so you can go ahead and configure those as well. But for this scenario I am not going to tell that thing. So how you can verify neighbor adjacency? So IP enhance IGRP, then after VRF, and name of VRF, and then your neighbors. So we got form neighbor adjacency inside RAID. You can verify on green as well. So green, hopefully, yes. Now as we know, the RIP has administrative distance is 120, and enhance IGRP administrative distance is 90. So we running both of routing protocol in RAID as well as green, RIP and enhance IGRP. So what we expect to see inside routing table of VRF RAID and VRF read, the network from the enhance IGRP, because it has lower administrative distance than RIP. So IP root enhance IGRP name RAID, VRF. So IP root and then after VRF name RAID, and good. You can see we learning network from the RIP, but you can also verify. So IP protocol we running enhance IGRP as well as RIP on both of router. So good. Now we have successfully performed routing using RIP, routing using enhance IGRP. This time I am going to use static routing as well. So branch 1, how we can perform static routing inside VRF? IP root, and where you want to go, the name of network. First you need to specify For whom you going to create static routing? So IP root for VRF, and then after the name of the VRF and then destination prefix where you want to go. I want to go 192.168.2.0 and then prefix mask 255.255.255.0. Since I am working on branch router, I want to go to network 2, and then after I will send that thing on 10.10.10.2. So good. So IP root VRF means static routing for VRF RAID to network 192.168.2.0. This is the mask. I will send packet out of this interface, and similarly put right there green. So GREEN. Good. Switch on the next router and implement same thing. IP root and then after VRF. Name of VRF is RAID, and the network which you want to access, that is 1.0, 255.255.255.0, 10.10.10.1, and next one is green one. So GREEN, and go ahead and check routing table again. So IP root of VRF RAID. So what we going to see, we have static routing rather than enhanced IGRP, as well as rather than RIP and enhanced IGRP. So hopefully you got all those things whatever I told you so far. One more thing I would like to mention, how you can use trace route. So for trace route, and then after also you need to use the name of VRF. From RAID I would like to use RAID, and then destination which you want to trace out. So 192.168.1.1, and again you can specify your source address as well. So from this VRF I that was RAID, I think so. I selected RAID one. From this VRF I trace route to reachability to network 192.168.1.0. So I hope so you got all those things, and I would like also say you again, inside your PDF file I have mentioned the troubleshooting command, how we can use, how we can see the VRF, how we can see the VRF root table, and all those things. So hopefully this is informative for you. Thanks for watching.